Okay, for today's lesson I want to do iteration. We have done this before, but I want to recap it. I'm going to do an example and then I'm going to put a question up for you to have a go at. Okay, so the example that we're doing is written on the board now. So using the iteration formula, x n plus 1 equals the cube root of 7 minus 2xn, and the starting value x naught equals 2, find a solution to the equation x cubed plus 2x minus 7 equals 0 to one decimal place. Now we don't really need to worry too much about this part onwards. All we really need to do is we need to start with this value and we need to keep plugging it into this formula until we end up with a solution that equals the same thing to one decimal place. Now, this 0 here corresponds to these little subscripts here. Here you can see we've got xn, which means the nth term. Here you can see we've got xn plus 1, which means the n plus 1th term, so it means the next term along. So we've started with x0, so I'm now going to find x1 using this formula. x1 is going to be the cube root of 7 minus 2, and then this bit here, this says n plus 1, this says n, so this little subscript here has to be 1 less than this subscript here, so that is going to be x0. Doesn't mean that we're multiplying by 0 or anything like that. This is just a particular value of x. And the particular value of x is this one here, is this x0, which is 2. So I'm going to substitute that in. x0 is equal to 2. And then I'm going to put this into my calculator to find x1. So it's going to be the cube root of 3, and that gives me 1.44224957 blah blah blah. Okay, now I'm going to do it again. I'm going to find x2 this time. x2 is the cube root of 7 minus 2x, and this time it's x1. That doesn't mean that this is 1. What it means is we already found x1 over here. It is this answer. So we're going to do the cube root of 7 minus 2, and then you can use the answer key on your calculator. That should give you 1.602535155 blah blah blah. Now we're finding an answer to one decimal place, and at the moment this answer, this x1 and this answer, they do not match to one decimal place, so we're going to have to repeat it again. So we're going to find x3. x3 is equal to the cube root of 7 minus 2 x2. This one here is always the term before this one here, and that is all the little numbers mean. This is the third term. This is the second term. We just found the second term here. So we're going to do cube root of 7 minus 2, and again you should be able to just use your answer key. In fact, at this point you should just be able to press equals because you've already got it set up with the answer. And we can see there, this is the example from the book, you should get 1.559796392, which is what I have got from my calculator as well. And now if we have a look at this one rounds to 1.6 to one decimal place. And this one up here rounds to 1.6 to one decimal place. So now that our answers are matching, that's what we're going to say our solution is. So we can say a solution is x equals 1.6 to 1 decimal place. Now I would like you to have a go at a similar question. So pause the video once I've made this big enough. Pause the video and have a go at this one, please. And then I will go through it to show you how to do it. Okay, so you should have had a go at this now. If you haven't, pause the video and have a go. We've got a starting value of x0, and again, this 0 just means it's the starting term. It corresponds to this n plus 1. We're going to find x1. Because this is n plus 1 and this is n, that means wherever we've got xn, I'm going to put x0 in. So I've got 2 x0 squared plus 11 over 4x0 so I'm just plugging in 3. And I end up with 29 over 12, which is 2.416 recurring. So then I want to find x2. Using this iteration formula again, that is 2 times x1 squared plus 11 all over 4 times x1. So in your calculators you can put 2 times answer squared plus 11 all over 4 times answer. And when I do that, the answer my calculator gives me is 2.346264368, blah blah blah. If I then just press equals again, it will give me x3, which gives me 2.345208118, blah blah blah. And if I just press equals again, because I've set it up with answer, it gives me 2.345207788. And we were asked to find the answer to 3 decimal places. Now if we have a look at x3 and x4, they are the same to 3 decimal places. Let's see what happens if we do x5. We actually get exactly the same answer as we got for x4, and in fact now if you keep pressing equals it will just keep giving you the same answer. So a solution is x equals 2.345 to 3 decimal places. Now I've put a worksheet up for you to do, but I am going to do some of the questions and then you are going to do a similar question from that worksheet. So the first question I'm going to do is question 1 from that worksheet. So we'll work through this one together and then you're going to have a go at a similar question. So the number of rabbits in a field t days from now is p with a little subscript t. And the way that we can work that out is p0, so that's our starting number, is 220. Every time we get 1 day further ahead, we do 1.15 times the previous day minus 20. So if I wanted to know the number of rabbits in a field 1 day from now, I'd want to be working out P1. That's going to be 1.15p. Now, t plus 1 corresponds to 1 here, so t must be 0. So I'm going to do 1.15 and I'm going to use P0, which was 220. So if I put this into my calculator, it will give me the number of rabbits in the field in 1 day's time. But we want the number of rabbits 3 days from now. Oh, confusingly, this says in a field and this says in the garden. So this might be a guessing game, but I assume the field is the garden. So for P2, we're now going to use P1 to help us find that number. And we end up with P2 being 241.5 rabbits. Now, because it must be an integer, it's going to be 242. For P3, we end up with 255.3, but again the number of rabbits must be an integer, so 255. So for that question, the number of rabbits in the garden or field 3 days from now is 255. Can you please pause the video and have a go at question 2 on the worksheet? So you should have had a go at question 2 on the worksheet, and for your final answer you should have got 57553. I'm now going to do question 3 from the worksheet. So using the iterative formula x n plus 1, oh, don't want that there, go away 57553, just move this down, no, okay everyone, I'll try pasting it again instead. There we go. It's all right. Okay. So using the iterative formula x n plus 1 equals 3 plus 9 over xn squared, and we've got x naught is equal to 3. We want to find x1, x2 and x3. So x1 is going to be 3 plus 9 over the term that came before it, which is x naught squared. So this is the term we want to find. This xn is the term before it. So for x1 we use x naught. So for x1 we're just going to end up with 4. For x2 we repeat, we do 3 plus 9 over, this time it's going to be x1 squared. And for that one, if you put it into your calculator, you should get 3.5625. Finally, for x3, we're going to use x2 here. And I get as my answer for that one 3.709141274. And that's all my calculator shows, so I've written down all of the digits because it has not told me to round. So, can you please pause the video and have a go at question 4? So you should have had a go at question 4 now. Pause the video if you haven't, please. But you should have got that x1 is 1.25. x2 is 1.095890411. That's all my calculator shows. And then x3 should be 1.190199669. Next question I'm going to do is question 5. So we are starting with x0 equals 3. Use the iteration formula 3 times. That means we're going to find x1, x2 and x3. We are using it 3 times. To find an estimate for blah blah blah, we don't care. It doesn't make any difference. All we need to know is that we're using this formula. So to find x1, this is n plus 1, this is n. So if this is x1, this becomes x0 because it's the one before it. This is n plus 1, this is n, 1, 0. And x0 is 3. We're given that in the question here. So for x1, I've got 2.7 recurring. For x2, I do the same sort of thing, but this time I'm plugging x1 into the iterative formula. And now that I've set up my calculator, I can just put answer in there. And for that I get 2.9072. Finally then, for x3, I know that's going to be 7 over x2 squared plus 2, but I can actually just hit equals on the calculator if I've set it up with answer, like I did here, and that gives me an answer of 2.82822478. And because the question hasn't asked me to round it at all, that is what I'm going to put on the line. I'm going to put the whole thing. I'm not going to round it because the question hasn't told me what to round it to. Can you please now pause the video and have a go at question 6? So you should have had a go at question 6. And your estimate should be 0.59931400006. Said that a bit like I was giving a telephone number. Okay, so next I am going to do question 7. So for question 7, part A is very straightforward. Find the values of x1, x2 and x3 using this iteration formula and this starting value. So for part A, x1 is going to be 5 over x0 squared plus 2, which is 5 over 2.5 squared plus 2, because x0 is 2.5. And for x1 I get 2.8. x2 is going to be 5 over x1 squared plus 2. So it's going to be 5 over answer squared plus 2. And for that one I get 2.637755102. And then finally I want to find x3. And I can just hit the equals sign again and get that x3 is 2.718622914. And that completes part A of the question. It's just asked me to find x1, x2 and x3. Now, for part B, it says explain the relationship between the values of x1, x2 and x3 and this equation here. Now, if you have a look at this equation, you might notice that it has a lot of the similar components to this equation. The reason for that is that when we use an iterative formula to find a solution to an equation, it's usually a rearrangement of that equation. So what we're going to do is we're going to try and rearrange this to make something that looks like this. So I'm going to try adding 5 to both sides first of all, because I've got this 5 up here. Then I'm going to substitute out an x squared because I can see I've got an x squared down here. And I'm going to divide through by that x squared. Then I'm going to add 2 to both sides. And if you compare that to the iterative formula, you can see it's very similar. Xn plus 1 equals 5 over xn squared plus 2. And here I've got just x equals 5 over x squared plus 2. So what we can say then is that the iterative formula is a rearrangement of the equation and x1, x2, x3 are estimates of the solution to the equation. Can you please now pause the video and have a go at question 9. So you should have had a go now at question 9. And for question 9, you should get that x1 is 1.25, x2 is 1.64, and x3 is 1.371802499. And the answer to part B will be very similar for the answer to question 7 because you can rearrange the equation to get the iterative formula. Okay, last example for today. I'm going to do question 8. So I'm going to work through question 8 and then you are going to do question 10. Okay, so for question 8, part A is show that this equation has a solution between 1 and 2. This is a very simple question. All you have to do is plug in x equals 1 and plug in x equals 2. So for x equals 1, we're going to plug 1 into this equation. And we end up with negative 2. Then we do the same thing but for x equals 2. And for that we get 9. Now, if the values we'd plugged in were a solution, they would have given us 0. But this one is too low, it's -2, and this one is too high, it's +9. We wanted it to equal 0, so because there is a sign change in the answers, that means the solution to this equation being equal to 0 lies between x equals 1 and x equals 2. X equals 1 excuse me, gave us an answer that was too low. X equals 2 gave us an answer that was too high. So an answer somewhere in between would give us this 0 when we plug it into the equation. Part B relates to Part B in the questions we've just done. So show that this equation can be arranged to give this, which if you look at Part C is going to be our iterative formula. And this equation here is the same as this one here. So all we're trying to do now is rearrange this equation in Part B to give this equation here. So I noticed that 3 is in the numerator, so I'm going to add 3 to both sides first. Then I noticed 2x minus 1's in the denominator, so I'm going to factorise out an x squared because there's no squared in here. I'm going to divide by that 2x minus 1. And then finally, I've got an x squared and there is a square root, so I'll just square root both sides. And that's Part B done. Now for Part C. So starting with x naught equals 1, use this iterative formula twice. So that means we want to find x1 and x2 to find an estimate for a solution to that equation. So for x1, we're going to do square root of 3 over 2 x naught, because this term is the one before this term. And if we put that into our calculators, we'll just get root 3. Then for x2, we're now using x1, which is the value we just found. And in our calculators we can put that in as answer. And I end up with 1.103395785, and I'm not going to round it because the question hasn't told me to. So can you now pause the video please and have a go at question 10. So you should have had a go at question 10. Parts A and B are very similar. You'll know if you've got them right because for part A you will find a solution that's too high and a solution that's too low. For part B you'll have rearranged it to get what the question's asked you to. And for part C you should get that x1 is 0.25 and then x2, which is also your estimate, is 0.2460937.5. Okay, so hopefully you're feeling quite confident with that. Can you please submit your answers for the questions that I asked you to do, which I think is all the even questions? Oh no, it's not, is it? It's going to be 2, 4, 6, 9 and 10. So please submit those on Show My Homework. And if there's any that you really struggled with where I haven't gone through the full answer, let me know and I will do a video.